Okay, so the purpose of this video is to go over how to find the roots or zeros of a polynomial function. This particular polynomial function has degree 3, which means we're going to have 3 zeros. That's the fundamental theorem of algebra, says that if the degree is 3, there would be 3 zeros. And likewise, if it was 4, there would be 4 zeros. We're not guaranteed that they're all rational, but there will be 3 zeros. Some of them irrational, maybe imaginary. We'll find out. So the first thing we need to do is try and figure out a list of possible rational zeros. So I'm going to say that's step 1 over here. List possible rational roots. So to do that, we use this rational root theorem, which says that all of the roots can be found with this formula. You take the positive or negative and you list all of the factors of the constant, which was 6, in the numerator, so that would be 1, 2, 3, and 6. Those are all of the roots of 6. And in the denominator, we list all of the roots of the leading coefficient, which is 1. So 1 is the only factor of 1, of course. So now you divide each of those numerators by 1, and you get your list of possible rational zeros, or positive or negative 1, 2, 3, and 6. So that's 8 possibilities altogether, because each of those could be either positive or negative, 1, 2, 3, or 6. From here, I would recommend using your graphing calculator to identify one that works. The trick is to go into the y equals function in your graphing calculator, type this function, and then go to your table, which is under second graph on the far right of your graphing calculator, and then you will type in these numbers until you find one that works. So try positive 1, negative 1, positive 2, positive 3, positive 6, negative 6. Find one that is a zero of the function. Find one that gives you 0. So the one we find that works is negative 1. So now we'll move on to step 2. That was where we tested the roots until we found one that worked, and it was negative 1. Now we move on to step 3. Once you find one that works, you're going to use synthetic division to find the quotient. So synthetic division, this will require 4 lines since the degree is 3. 1, 2, 3, 4. And I write my coefficients of the polynomial on the line. The leading coefficient was 1, then it was 4, negative 3, and negative 6. The number we said that worked was negative 1, because using our graphing calculator we found that f of negative 1 for this function is 0. So negative 1 we know is a 0 of the function. We're going to test it, find the quotient, and use that to find additional zeros. So I multiply 1 times negative 1 is negative 1 for synthetic division. It's multiply and then add. 4 plus negative 1 gives you 3. Then you multiply again. 3 times negative 1. You're multiplying each time by that input value, the negative 1. So negative 3 plus negative 3 is negative 6. And finally, we multiply one more time. Negative 6 times negative 1 again is 6. Add and we get 0. So that would be the remainder, which means that this was indeed a 0 of the function. From here, you can take the quotient, which is x squared plus 3x minus 6. We can find the zeros of a quadratic equation. So as soon as you have a quadratic equation, you can stop and find the zeros from there. We would try to factor it, and since this quadratic does not happen to be a factorable quadratic, we would need to use the quadratic formula. So we'll say x is negative b, which is negative 3, plus or minus the square root of b squared, that's 9, minus 4 times a times c, all over 2a. So 2 times 1. Then we simplify that. So we get negative 3 plus or minus the square root of 9 plus 24 all over 2. We get negative 3 plus or minus the square root of 33 all over 2. So that means our list of zeros would be our -1, which we found originally. And now these irrational zeros, -3 plus square root of 33 over 2, and -3 minus square root of 33 over 2. And you generally don't have to write them separately. You could write those together as just -3 plus or minus. As long as you're aware that they're two different entities, two different zeros, because in the end we're supposed to end up with 3 zeros, which meets our fundamental theorem of algebra, which says that if the degree of the polynomial is 3, then there should be 3 zeros. And that's it.